From here, we'll get more into the idea of sampling. So we've decided that some populations are just too big to get in touch with every single person, and so we'll use a sample to try to gain information about the population. And as we said, we want the sample to be representative. That is, we want the sample to look like the population, to have those same characteristics. And so the best way to do this is to have a type of random sample. And there are lots of different kinds of random sampling. In this class, we'll look at four quality types of random sampling. So the first one is just the simple random sample. This is one that you might be familiar with already. In a simple random sample, each member of the population is given some sort of number or identifier. Then we use some way to generate random numbers to pick. We use a random number table or a computer program. And so each person in the sample is equally likely to be chosen. So like with students at TCC, every student has a student ID. We can use those as identifiers, and we can use a random number table or a computer program to generate digits and pull students based off of their student ID number. We can use something as simple as passing out the numbers 1 through 50 in a classroom, and then putting the numbers 1 through 50 in a hat, and then randomly picking 10. We would have a simple random sample of those in the classroom. Everybody has an equal opportunity to be picked. From there, we could head into the stratified sample. And in a stratified sample, we take that population when we divide it into groups, and in the stratified sample, they're called strata, and then a proportionate number of individuals is taken from each group, that is from each strata. So you take your population, you divide it up by certain characteristics. So in the example in the notes, we're talking about, you could take the student population at TCC and divide students up by major. So you could have all your nursing majors together, you could have all your engineering majors together, all of your business majors together, all of your math majors together. And then from here, you use a simple random sample to select a proportionate number of students from each major, from each pathway. And the key that it is proportionate. So you wouldn't have an equal number of nursing majors and an equal number of math majors, because nursing is a more common major than math majors. So you would expect to have more nursing majors in your sample. You would expect to have fewer math majors in your sample. But this way you would get someone from every major into your sample. So again, with stratified sample, you split the population into groups, and you pick a few people from each group. Another way to think about it is classrooms on campus. We could go and see, what was the parking situation like for students at 9:05. We could go to all the classrooms with classes at 9:05 and split the campus that way. So if you're in classroom SM137, you're one strata. Classroom SM136 is another strata. Classroom SM135, another stratum. And then we could pick a few students at random from each class using our numbers in a hat system. Larger classes should have larger numbers of students pulled, and smaller classes should have smaller numbers of students pulled. Similar to the stratified sample, we have the cluster sample. And just like the stratified sample, we do divide the population up into groups once again. And this time the population divided into groups, we call these clusters. So in a cluster sample, they're clusters. In a stratified sample, they're strata. But then instead of selecting a few people from each cluster, some of the clusters are randomly sampled. And if a cluster is sampled, everyone in that cluster would be picked as part of the sample. So going back to our parking situation at 9:05 in the morning for those 9:05 classes on campus, I would still, divide the campus up by classroom. SM137 would be one cluster, SM136 would be another cluster, SM135, SM134, and not just the science and math building, but all over campus. And then each of those clusters would get a number assigned to them, or we could use their room numbers, however we want to do it, and randomly pick from those And if the cluster gets picked, everyone in that cluster is part of the sample. And if the classroom or the cluster doesn't get picked, then they are not part of the sample. So, maybe classroom SM135 gets selected, but 136 and 137 do not, so they would not be part of the sample. And this tends to be okay when your groups are similar, from classroom to classroom to classroom, you'd have a variety of students. But when your groups are diverse, you might not want to use the cluster sampling method. Again, going back to splitting the college up by major, if we left out some entire major groups, we wouldn't get an idea of the student experience. If we didn't select nursing majors and we didn't select engineering majors and we didn't select business majors just by random chance, we didn't select those large groups, but we selected majors that aren't as common, anthropology, math, chemistry. We would get some biased results with that cluster sampling. So stratify just a few from each major would give us what we would need. And then finally, for our good random sampling methods, we've got the systematic sample. And with the systematic sample, you select a starting point, random chance, random number generator, or number table, and then take every nth piece of data from a listing of the population. So there's our systematic component, the nth piece. So you randomly start at the 37th person in the population, and now you're going to select every 10th person in the population list. So it's like person 37, person 47, person 57, person 67, 77, so on. So you've got this system that you're working with. You've got to have all of the population listed out, though. So you could use a phone book to do that. If you had a list of all the students at college and their student IDs, you could line them up in an Excel sheet and then find your starting point and then go by your nth term, maybe every 25th student or whatever it happens to be. Now, true random sampling is done with replacement, but for practical reasons, simple random sampling is done without replacement, saying that if one person is selected for the survey, they don't go back in the pool to be picked again. You don't want to pick the same person again and ask them the same questions. They probably wouldn't want to participate once again. So once a person is selected, they're not selected again. So it's done without replacement. They can't be replaced once again. So from here, in the next video, we'll go to sampling types that you want to avoid.